I'm here to talk about this saga that I went on. A years-long saga, hundreds of hours to build custom motor curtains. You could see it right behind me, and here's the control panel. Because I didn't want to spend $100, $200 buying a solution. I wanted to do it completely from scratch. So here are some close-ups of the end result, and this will be a lecture style thing where you can see me talk through the various challenges that I had to go through iterating to come up with this design and not just buy something. I'll splice in two videos. You can kind of see over here in the bottom corner one of the first versions that I did, which was a quick hack. This was something that I threw together. But first, let me show you the end result. Yeah, so you can kind of see the end result. I have a little control panel. I can push it. There's this window right next to my workspace. And yeah, and then you can kind of see also I have two different windows that I control with this. One that is like kind of a window in front of my workspace, and then I have a kind of balcony window which I'm standing right in front of. Yeah, so the first version was I had this open window. Yeah, I had this open window. At first I thought, hey, let me just make a motor, gear it up. Turns out that these hobby motors are very weak, so I made a worm gear. And this is a little crop, but you can see I kind of held it together with like a wooden rod and very thin prints and zip tie, binder clip. It's very janky, but overall it worked. And because it worked so well, I wanted to iterate on it more and do like a really good design. So I'm gonna kind of talk through the process of doing that, doing like the visual design, how I wanted it to look and fit in with the rest of my furniture and stuff like that. The mechanical design, like how everything moved. There's various electronics and programming to control the whole thing. I did a couple of different iterations. So I want to talk about like, hey, if you are interested in projects like this, or you do projects like this, or maybe you did projects like this in the past and you just want to watch someone see how someone else did it. Maybe give me some tips, hopefully, like, hopefully someone who's really skilled can give me some tips. Maybe I'm better at you than some things and you're better at me at some things. We can, share knowledge with each other. There are some various, so this is not like focusing on one thing. This is very much like I want to complete this project and I'm using a bunch of tools to get it done. And I really designed this around spare parts. This is something that I just wanted to do just for me. I didn't really like try to source things from scratch. It's like, hey, I have this stuff lying around. I don't want to throw it away. I want to design around these parts. So that's kind of my mentality. But first, let's talk about why would I even like do this, right? You could just go and buy something like this. It's not really a big problem. But for me personally, because of my lifestyle, this is something that I use a lot. So I have this big window near my workstation, and sometimes like I code and I need it to be very dark. So I want the shades to be down, and other times I'm working like putting stuff inside like, small electronics boxes, and I need a lot of light. And, where I live in Los Angeles, there's a lot of natural light. So being able to control that is really helpful. Also, like I live in a small place, I don't have a lot of space. And the way that I have my things set up, I have this giant window, which is cool, but I have it blocked with my workstations, basically my computers and my tools. And I like to work in front of the window because it's bright, but because I have everything in front of my window, it's very hard to access. So just having like an automatic motorized thing, it helps a lot because I use it a lot. And when I did that quick hack, it was something that like, I was like, I don't know if I'm going to really use it. I ended up doing the hack. It was one of the things that like I spent 100 times the effort on stuff that I didn't use as well. This was something I did quickly, and I just used it every day, multiple times a day. And yeah, it's a really great thing. So again, I'm not one of these persons who's like, I'm going to I'm going to build something from scratch just because I like it being handmade. I'm not one of those people that's like, and I do get this criticism. Why not just buy it if you could build it? And to kind of show you why, you could do an Amazon search for motorized shades. And, part of this is the degradation in quality of Amazon stuff. But like, first of all, right away, you get a bunch of sponsored things that's like not the best. And then you scroll down and it's like, okay, some of this is like a smart blind. That's like, it's not the curtains, it's just the blinds part if you already have blinds. And then like all of these kind of look the same and they're advertising like smart features, which I really don't want because I do development of like a lot of Bluetooth and Wi-Fi stuff. I don't want a bunch of devices clogging my network. Also, it's not a big priority for me. I'm not one of those home automation people. That's like really more of a con than a pro. And then, like it's really hard to trust reviews anymore. They're fake reviews. Sometimes I see something, it looks affordable, I go to the reviews and they're all fake reviews. But that's just Amazon, right? Like you type in something, there's thousands of items, you don't know which is real and which is a scam. Okay, how about this? How about I go to Home Depot and there are fewer items, it's higher quality, I can go into the store and look at it, I can return it, which is okay. But like then you can see, wow, the really cheap stuff, it starts at like $100, and if you go and you click the options, $100 is like very bare minimum. Usually it's like a couple $100, and even if you deal with this, you have to deal with installation, it doesn't fit right. I'm like, hey, how complex can this be? It's just a bunch of fabric, a little rod, a motor. This should be like one of the simplest things ever. And it turns out it's a lot more complicated and it probably is worth it to just buy something unless you're someone crazy like me. So I would recommend you not do this. It took me a lot of time. It's not worth it for the money. It's also not an easy project. Also, this is for a certain subsegment of people. Like for me, I'm just space constrained. So having something like this is really useful. For most people, you're probably not going to just put stuff near your window. It's not a big deal to just have some extra space and move stuff manually, but I'm a very special use case. So I say, fuck it, let's do it. So here are my skills. Overall, I would say I'm like mid-level in mechanical stuff. Like I can design things. I know a bunch of fabrication techniques. I'm like not really good or an expert in anything. There's a lot for me to learn. There's a lot of places where I can get better, but I would say I'm mid-level. I'm not like a noob. I'm not pro. Electronics, I'm more of a noob. I can get things done, but they don't work well. They break a lot. There's a lot that I don't know, a lot that I can improve upon. It's just a lot more challenging for me. My background is in software though, so for the programming stuff, that's super easy for me. I'm probably not going to talk about it that much because, well, so I don't run into a lot of challenges in that domain. And probably the stuff that I do talk about is very advanced, and like there's just probably nobody who's like, okay, I'm really good at software, but I'm a noob at these other things. Please explain to me, So I'll probably just gloss over that. Yeah. So that's my skill level. In terms of stuff that I had a bunch of spare motors, so that's one of the reasons why I would do a project like this. I also have like a lot of parts. I have just, over the years I've accumulated a lot of hardware, so it's pretty easy for me if I want to design something to know that I don't have to run to the store and do a bunch of trips. Not to say that I bought nothing, but I would say the majority of items I already owned, and I only ordered a couple of parts for this. I also have a 3D printer, so I can just design and make a lot of my own stuff. And then I have tools, for doing if I need to solder something, if I need to cut something, I just have all that ready. If I need to program something. So let me take a little breather. Yeah. Thank you for bearing with me if you are watching, by the way. I'm honestly, I'm doing this mostly for myself. I'm experimenting with this new format. I just hate editing videos, you know? I would rather just stream it live. And for some reason, like, I'm good at doing live talks. This is a huge aside, and I might cut this out, but I might leave this in. And my goal is not to cut stuff out. I would say I'm pretty good at like doing public speaking and giving talks. Like if I was in a room full of people, I would be a lot more comfortable and this would come out a lot more naturally, which is weird because usually it's the opposite. Usually people are fine like talking by themselves. And when they get in front of a lot of other people, they're self-conscious, but I'm just not one of those people. And like editing, I just find it so tedious, and I'm such a perfectionist. If I could just do it live, that's just so much easier for me. So this is what I'm going to do. And it's a struggle because I can just go down so many rabbit holes and I can nerd out about so many things, but I want to just make sure I like go over the whole project and summarize it. Yeah. Okay. So let's talk about the first design that I did, which was a quick hack. Overall, like it worked and it did its job, but it was very bad. You can see a little preview, like look, wood, some plastic, right? A breadboard, wires. You can see that's a Pi 0. So it's like one of those small $15 Pi chips, and it has Bluetooth and Wi-Fi. Originally, my plan was, hey, I'm going to automate my window blinds. When I say automate, I mean motorize it. But originally, I was going to automate it. I was like, hey, I can make it like an alarm clock where it like, you know, based on the time of day, can go up and down. And also, like, let's say I'm in bed, I'm coding, and oh, I want more or less light. I could just type a command, and then it'll go up and down. I actually programmed that. That was the first thing I did. And it actually turns out like after the novelty wore out, I never used that. I just had like the simplest, like two big blue buttons, one button go up, one button go down. And it was like the size of my palm. And it was so fun to just smack that big thing, or I can hold it down to control it. It was like the simplest hardware ever, but it turned out that that was actually what I wanted and actually what I liked. Like all this fancy stuff, you know, I don't care about it. I just need a simple motor that goes up and down. So I actually ended up taking out the Pi, replacing it with just an Arduino microcontroller, and just recycling the Pi for another project. Let's see, talk about gears, control panel. Oh yeah, I also had like a really janky control panel. You kind of saw that in the video earlier. But yeah, that was kind of an afterthought, which I regretted because I used it so much, but you know, not too big of a deal because it's a functional thing, right? I didn't make it to look pretty. And then also with the gears, you know, okay, I keep saying that it worked, but it was bad. Let me just, oh yeah. So I keep saying that it worked, but it was bad. I mean, I used it for over a year because, you know, I did it. I moved on to other projects. What was good about it was that, you know, well, okay, what was bad is because it was a worm gear, it had a lot of friction and it was geared down so much. So it worked, but it was very noisy and slow. And I didn't really care because I just press a button, you know, and if it takes a minute or 2 minutes, it doesn't matter to me. It's not ideal, but it works. Yeah, noisy and loud. I thought I could do better. The only reason why I revisited the project was because it got fried. My roof started leaking, and then, you know, got some water, and then it kind of fell off. And then, you know, I said, hey, let me, like, because I used it so much, let me do a better version. And I identified, because I used it so much, a couple of specific things that I wanted to do better. I wanted to make bearings lower friction, so that way it would be quieter, it'd move faster. Yeah, I also wanted to, like, I just used one of these dumb cheap servo motors. You can get them for a couple bucks. Even in bulk, you can get them for under $1. But I had some, you know, I had some pretty high-powered stepper motors lying around. I said, hey, what's good about steppers is you can control them a lot more fine-tuned. You know, the cheap servo motors, you can't really control them that well. But you can control a stepper like pretty well. And then also, like, I just used kind of like a sheet that I had lying around, which looked really cool, but was not ideal. So I wanted to say, hey, let me like think about the fabric and the design and stuff like that. Yeah, so overall, rather than just have a janky hack together thing, I wanted something that would be sleek, maybe close to something that you would buy in the store, maybe even better, because a lot of these products, they aren't designed very well. Also, I wanted to do something really cool, like, again, because it was like, uh, because I made it such a long time ago, I've leveled up in a lot of areas. I wanted to try this technique of using steel dowels to design it with using steel dowels in the assembly process. It's just so much better than doing things with screws, or even there's a temptation when you do 3D printing to just plastic print everything. I am not part of that camp because 3D printing takes so long. It's better to design things in a modular fashion and plug them together. That way, if you mess up one part of the 3D print, like if it's a 12-hour print, you don't have to redo the 12 hours. You could just redo like the 2-hour, part that's a fifth of it. But the problem with that is now you got to connect them. So it's like, okay, do you permanently glue them together? Then it's basically the same thing. Or, do you make them friction fit? In some cases, that's good. I think the dowels is really great because if you do, screws are the best way, but they just take a long time. And then you got to do the screw shaft and the head. Sometimes you run out. With the dowels, it's just a hole. It's just so easy. Got that from the Rack Robotics guys. So it's great that they share that. I also want to do better wire management. I just kind of had everything like flopping about. And because the design was so simple, it worked. But I wanted to not only have that window, but my balcony here be motorized and maybe add some more functionality. And I knew that if I did that, then I would have to, like let's say I have the wires just hanging out and I knock something loose. Okay, I could just plug it back in. That's okay if I have, 3, 4 wires. If I have, a dozen, 2 dozen wires, basically the wire management worked for a simple project. It's not going to scale if I want to make it more complex. So I wanted to come up with solutions to handle that. Also, because I was just interacting with the control pad so much, I wanted to do a really good job on that. So I did that. I did this new version, and there were some challenges, right? I did the steppers, and I used some spare chips, and they were underpowered, and actually one of my breadboards lit on fire because it was just trying to draw too much current. So, annoying, but I fixed that. I also did, right now I'm good, I've designed hundreds of 3D printed parts, and I've printed them. I mean, all the parts I design, I pretty much print for myself. I don't really share any of them. I would say maybe half of the parts I print are ones I designed, half of them are parts other people designed. So I'm pretty good at designing for manufacturing to like, okay, the layer lines and the strength and bed adhesion and, integrating with, screws or whatever, what have you. Design for manufacturing, I'm pretty good at that. But designing for assembly, usually I'm doing things that are just like one-off components that exist, individually, or it's part of a robot. Usually, I think I underestimated the design for assembly. Yeah, so I can kind of show you, here, let me show you this. This is easier. I have a little, I printed a little scale model, right? And if you can kind of see over here, man, holding this mic right now, I just kind of realized this is going to be really tricky if I want to hold something up to the cam. But, yeah, so basically I have to mount it to the wall. I also included like little steel roller bearings in there. If you can kind of hear this, you can kind of see them inside. Oh yeah, and then I have this little cap that slides on. This is a friction slide thing. Yeah, you can kind of see that. So that covers where it screws into the wall over here. Installing it and assembling it is really hard because, yeah, basically you have to reach up and like I did this little test, and this test worked great. The test is not indicative of the actual install. So while the first version worked, it was really a pain to install. Yeah. So, I mean, I want to talk about this more later. So let me just come back to this. Another key mistake I made was initially I designed it to look really well. Like for example, this doesn't really show well on camera because it's all black, which is a feature, not a bug. I wanted it to kind of seamlessly blend in. I want me to not pay attention to this. The problem was, I didn't get the mechanical design perfect. So when I made the like finishing system, okay, I designed it, I made it look nice. When I installed it, I'm like, oh man, I have to make some changes. And then basically all the work I made with the aesthetics, with finishing it, was wasted. And it is very motivating to have something look good and see that in a model and be like, and then also sometimes you need to change the mechanical design around how it will look, how you will finish it. But if you ever have to change something, you generally want to hold off finishing to the very end, and I just made that mistake. Also, there's another thing. I have a little prop, but here, I'll do this. Yeah, so I kind of designed it around these wooden dowels, and one thing that I didn't account for, and you do things in the modeling software and everything is rigid, but this has some give, especially as you lengthen the rod. So because it had a bunch of give, it caused the gears to misalign and cause some problems. So you live and you learn, right? Luckily these things are cheap. There's other solutions. Oh yeah, so you can kind of tell, I did this more complex version, which was supposed to be better, but a lot of problems, right? Because I used thin fabric, which had a lot of advantages, there were some disadvantages. I just bought it. I didn't get stuff finished. Sometimes the fabric would get misaligned, and then it wouldn't completely unroll evenly. And you can kind of see in this little picture down there, it doesn't look that nice and it doesn't work as well. So that's just something I had to address. Also, another thing too, I have this, the stepper is a 12 volts, so I have this 12 volt power supply. Man, these barrel jack connectors, I do buy these cheap power supplies or recycle them. They all stink. I just hate them so much. But hey, stuff you gotta do. It did work though. I put it together and there were some minor issues. A lot of minor issues. But overall it worked, and with not too much effort. And here's kind of like a little mock of the this is the new control panel design that I did. This looks very sleek. I have a little bit of foil that's a capacitive touch button, and this actually, I put in a little motor and I had it buzz like your phone kind of buzzes, and that was really fun to program. But yeah, it was just more of like a, I don't know, I ended up just not doing it for I took out the motor version. It's not really necessary. It's kind of fun, good for other projects. Also, I had a better bearing system to reduce friction. That way, I could speed up the motor and it's quieter, and that worked really well. It's basically whisper quiet, and it moves a lot faster. But because the friction is so low, when I power off the stepper, sometimes the when the stepper is powered on, it's very accurate, but when I power it off, sometimes it unravels a little bit, or if I save a state, oh, it's halfway up, it can be pulled down very easily, let's say I tug on it, or various reasons. So actually having less friction adds more problems. And then there's also I made this kind of complex state management thing where I can keep track of things, where it would know when it's at the top or when it's at the bottom. It turns out that's good if you're going to keep it plugged in always, which it is 90% of the time, but especially when I'm iterating on it, sometimes I'll unplug it, and when I unplug it, it resets the state, and it's kind of annoying. I could say, okay, it's always at the bottom when it's powered on, but because it's the stepper motor, it keeps track of the motion, but it can drift, right? Because of, the low friction, and also, with power off and power on. So I don't actually have a measure of the ground truth of how up and down. So I needed to fix that somehow. Whoa. Okay, yeah. So I did this window curtain, new version, bunch of issues. I had to do basically the same system for my balcony, which was less of a priority, but something I eventually wanted to do. And because my window and my balcony are right next to each other, I can recycle the same control panel. So I wanted to do some fixes when I did the balcony thing. And I could take the data from what didn't work and fix that. So one of the things that didn't work very well is I attached the fabric to the dowel, which moves it, using tape. And I always hate using tape. It's just so easy, so quick, but it doesn't work well. Mechanical fasteners are always better. So yeah, I just kind of bought the bullet and bought a staple gun. And, buying a staple gun, I run into the same problem as like shopping for a motorized curtain. It's like there are all these brands, all these features. What do I really want? Project Farm has a great video on electric staplers. I would watch that, and that just gave me all the data I needed to make the right purchase. I absolutely love Project Farm. The only thing, so Project Farm, he'll buy like 10 different types of like a staple gun, or like the last video that I really love was laundry detergent. He bought 5 different types of laundry detergent and he did a test, and like, yes, that's what I need. I can't tell just, reading reviews. There's so many mixed opinions, whatever the manufacturer says is propaganda. He just, no sponsors. He buys a bunch of stuff. He does a side-by-side comparison. You could just skip to the parts where you care about, and that guy's a saint. The only thing that he doesn't do is durability, because he'll like buy 10 of a product that's new, and he tests it with data. The only thing that I would actually look for in reviews is like durability, because someone can buy a tool and maybe after a year it breaks. If he buys it new and tests it, he doesn't know that. Anyway, yeah. So I got the staples, attached it, worked out great. Also to prevent it from getting to keep it straight, so it basically wouldn't get off balance, which even if it's a little bit, sometimes it compounds, right? Like let's say there's a breeze, it can go a little bit, or it gets snagged, whatever. I'm moving something. I actually added like I like sewed a little pocket in the bottom, and I added a wooden dowel. So that actually works really well. It just kind of weighs everything down and keeps it balanced. It added a new problem though. Because there's such low friction, it actually makes it, sometimes it drags the curtain down even more. So that exacerbated the problem of it having too low friction. And when it has extra friction, sometimes it's out of position, or when it's powered off, because I don't want to be like powering on the steppers always. Then I'll just like drain electricity. I want to power it on when I have to move it, and then power it off. And steppers are great at holding stuff, but once it's powered off, like let's say I move it up, it powers off, the rod is weighing it down, it'll unravel a little bit, and that's just so annoying. So I need a solution for that. Also, installing it was such a pain because I basically designed my own ball bearings, and you can say, I'll address why later, but I made it so that I installed the steel bearings after I put the assembly on the wall. And that was just so annoying. It's just so easy. Like, it's really high, it's on the wall. So I just separated out the system, right? It's also like impossible to swap. So I separated out. I made bearing assembly, and then I made the wall assembly into two separate sub-assemblies. So that's good. Eventually I'll have to change the first one, let's say 2.0 to 2.1, the new system with the easier install. I'm not looking forward to that, but that just shows like how great 2.1 is. I would rather do 10 of the 2.1 systems with the separated bearings than 1 of the 2.0 systems. So yeah, anyway, I know I'm saying there's a lot of problems, but I unlocked 2 extra side quests, which are valuable. I wanted to make extra curtains to hide some of my storage, And I also wanted to add, just to solve all my low friction problems, a locking motor. So have it so that when the stepper motor is powered off, it can't move. And just to like talk about it again, like going from this hack, which 70% is maybe an overestimate, but it worked. There's a lot of things wrong, to like, okay, maybe a system where it's mostly good, 90% works, only minor gripes. It took 10 times the work. So much more effort to do this. So definitely it's not worth it at this point, and it didn't pay off. Unless the only exception would be like if I had to make like 10 of these or 20 of these. Or, you know, just for if I wanted to do it for my pleasure, if I liked it, which not particularly like it, or if I wanted to learn a couple of things, try design techniques, which I am doing. One good thing, one good side effect was I had curtains for storage and my printer. So you can kind of see over here, you know, actually right next to the window, which you can see in the background, I have shelves full of like tools and like project boxes basically of like, you know, I have electronics equipment, and then sometimes I'll have like half of a project, like parts, and I'll have like, you know, stuff for gluing and bubble wrap for transporting things, and I have my 3D printer. I also have that little curtain, and I'll play a video here. I'll splice in a video of me actually using this. But yeah, basically I have all these like equipment, which is part of the reason why I needed this curtain to be motorized in the first place. But now I have this really nice system where I can hide all of these tools and show all of these tools. Now, why would I do this? This seems like a weird thing, but this is actually something that was very quick for me to do and had a lot of value. Originally, I planned to, one of the reasons why I did this whole motorized curtain project was I not only wanted to motorize curtains, but I wanted to motorize artwork. So you can kind of see my poster. This is, you can't really see any of the background stuff. But yeah, this is like some artwork for one of my games, 4D chess. And, you know, I go from time to time, I'll like hang up a lot of artwork. I really like flowers and like landscapes and classical art. And like sometimes I'll just like hang them up everywhere. And I love it for inspiration. But other times, like, it's kind of distracting. I end up staring at them. I want to just have blank walls or whiteboards and just focus. So I kind of oscillate every maybe couple months, and really only every couple months I have the time. I would do this more often, but yeah, I switch between these modes of like wanting to become creative and brainstorm and be inspired to like, okay, I want to be minimalist, I want to focus, I want to be productive. So I thought that if I could just kind of have a bunch of artwork that I could motorize and press a button, it'll show a bunch of artwork, press a button, it'll hide everything and have blank walls. That would be a really cool feature. And I could build that in while I'm doing these motorized curtains. It ended up, you know, being such a pain, like designing this stuff, doing the electronics, which I'm going to talk about later, that I decided like, hey, I'm not going to be able to do this kind of art project, like variable art project. I still think it would be really cool, but just too much effort. But I had an idea. So I have these this storage space, and sometimes, you know, I want to rest. I want to not look at it, right? It's like chaotic, it's mess. Other times I want it to be open, want it to be accessible. So I had all this extra fabric. I had designed these systems. The good thing about this is because there are tools, they are accessible by hand. So I didn't need to do any electronics or motorization or wiring. I could just reach out and grab it because these things are things that I need to grab. And I could very quickly show or hide these tools. So I have one mode when I'm trying to be productive. I could reveal everything. It's super, you know, accessible. Another mode, maybe I want to rest. Maybe I don't want to think about work. You know, take a little break. I can just hide everything, and that's super quick, super accessible. It really helps, like visually, like, okay, hey, it's just a white curtain. It's not all this crazy design. All this crazy, not design. All this crazy equipment. Now, you might think that this is like kind of a stupid thing to do. Like, why don't you just get, like a normal person, just get cabinets and open and close them? Yeah, well, they stick out, right? The great thing about these curtains is it compresses to a very small size, And the advantage of cabinets is it's hard, so it's protected, but I don't really need these things protected, right? So yeah, overall, great success. Let's go back to the main quest, right? Which is actually doing these curtains. So yeah, had so many problems with friction. I ended up getting around that by implementing locking motors. So basically a linear actuator that will have a clamp that works just kind of like a car brake that'll hold onto the rotating axle and stop it, which involved a lot more wiring. So I had to redo the control panel. And one of the things that really sucked about the control panel, I have this old version here. I can kind of show you, right? I used foil as capacitive touch, basically as buttons. And I really like this because there are no moving parts, so things don't break. It also looks nice. It's like I can get a metal finish with using foil, which is cheap. And then I just cover it. Yeah, so, but basically you somehow need to connect the foil to a wire. You can see kind of in the bottom corner, these wires. And then that goes onto the circuit board, which registers your touch, whether you're touching or not. And another thing cool about the capacitive touch is you don't even need to touch it. You can kind of hover over it. But in this case, you know, I touched it. So what I did is, there are a couple different ways you can attach wires to foil. You could tape it. Again, I hate tape. You could solder it, permanent. You know, there are disadvantages to that. I wanted to find a good solution because I really like using this, but it's just a pain to set up. I'm not sure you can see. Yeah, so the way I did in the first version of this new control panel is I have a screw and a nut. And basically the idea was to thread the wire around the screw and then clamp it down with the screw and the nut. So that way you always have contact, it's there. Good idea in theory. In practice, you know, if you get one working and you do another, it can come undone. And it's since it's so small, it's so finicky, not great. It worked, but it was just such a pain. I think it took me like an hour to get everything done. And then it's like, okay, an hour is not a lot. Maybe I'll redesign the system and that'll take 2 or 3 hours, which will save me time. Maybe instead of an hour, it'll take 5 minutes, but still that's a net loss. But I think the thing to get at is this approach does not scale. If I wanted to add a lot more buttons, then it would not be worth it. And then also if I have to disassemble it and reassemble it, it's a huge pain. And that discourages me from disassembling and reassembling and making things better. So I needed to find out a better way to do the assembly of the touch panel. And how I did that was I split things up into different parts. I had just the wire stick out. Then I had like a kind of middle part which had tape that goes that contacts the wires and goes around to underneath where the foil is. So rather than having something screwed together, it's just kind of sandwiched. So I have a layer that's wire, copper tape, foil. And it's all friction fit. And you can kind of see like in the cover, you could see those like in the corner of the basically cutout, right? The new cutout version. Oh yeah, that was supposed to be black too, but I just got lazy and I had pink filament. Sorry for that tangent. Yeah, basically within those four, you can see kind of 4 squares on the corners. Those are embedded nuts. So I put in some nuts and yeah, basically the cover, when it mounts, it also friction fits the foil and the pads. Now, did this work? Yes. It works 90% of the time. It's not perfect. I still have to iron out some kinks, but overall it was a huge improvement. But you know, some new techniques. So yeah, also there's still some like problems with the fabric situation. I know how to fix them. I'm gonna hold off for now. Still a lot better. The second one, you know, this is basically the same design as that first new redesign. There's that version 1, which is kind of the janky one, version 2, which is the new one, and version, let's say 2.1, 2.0, 2.1, where I took the learnings from 2.0 and I implemented them. Let me talk about 3D printing because I did 3D print a lot of stuff for this. One great thing is testing sub-assemblies. Like, I already showed you this, right? I showed you like the little button sub-assembly. Because 3D printing, the disadvantage with subtractive versus additive is it just takes so long. So whenever you can have a risk of failure, I always like to just do a test with just the subassembly, and even if possible to modularize things. So if I do fail, I can split it apart. Here's something like embedding nuts. I'll talk about that later, but let's say I had to do a part with this. Like here I have 10 embedded nuts, or over 10, I don't know, a lot of 15 embedded nuts in this part, and to just take 30 minutes and print that out versus, let's say you have a 10-hour part and you have to do a couple of iterations, it just saves you so much time. Another hack too, like oh man, seeing black is so bad. Yeah, but I had a USB port and it was undersized. So one great thing about 3D printing, rather than machining something out of metal or even other types of manufacturing, is it's super easy. Like here's like a super pro tip. You get one of those $20 3D printing pens, plastic pens, and it usually comes with extra filament, but you can save your like let's say you're at the end of a spool, you can save that filament. And what you could do is, you can like take a soldering iron and you could always just, like let's say you need to cut a part of 3D print, you can cut it apart, right? But sometimes, it's a hole, you want to increase the size of a hole. You can use the pen and kind of melt it, and it gives you a very fine point. Now, some of you may say you can do it with a soldering iron, but like, then you got to swap out the tip. It's just annoying. It's nice to have that dedicated 3D pen. Also, if you take off too much, or if you need to add something on, or even fuse something together, like in a kind of quick way that's like not too structural, you could just use that to add a little bit. So that's one of those things that really, like, I would just highly recommend get a 3D pen, and it really will help you. Like if you're the type of person, if you're just someone who like downloads stuff off the internet and prints it, but if you're using this to prototype things, and if you're using this to design really complex parts, 3D pen, awesome. Also, I gotta make a dedicated video on this because this is a huge tangent, but I have moved from let's see. So these brass inserts. Look, I know that's really popular. So there's a couple ways if you want to attach things. You can friction fit. That's nice. You can glue stuff. That's nice, permanent. Friction fit doesn't always work that well. It's kind of finicky. You can kind of see here in the bottom, because I'm attaching a circuit board, I have embedded nuts. So I do a print, I pause, I insert a bunch of nuts, I print over it. And then you can also see this side channel where the cover mounts. I don't have a nut in there. I just have a long hole. And when you thread stuff in, these are nuts in here. When you thread stuff in, yeah, so, oh man, how much should I talk about this? Basically, I'm team embedded nuts now. It just works so well for my use cases, which is mounting small. If you have to do large threaded stuff, then and if you have a lot of space, then just printing a hole and threading into that hole, and if you don't have to disassemble and reassemble it a lot, just printing a large hole and threading into it works. But if you are using very small, if you don't have a lot of depth to work with, you're working with a really thin part, you don't have it doesn't work well, just threading directly into plastic. The thing about brass heat inserts, it's very hard to align. I know there are tools to align, but then that's like, okay, now you double the footprint of a 3D printer, and then it's still really annoying, a pain in the ass to get it set up. And then you're also severely constrained by using those tools. Also, they're not that strong. I've had them strip, and the two use cases where I use inserts is I have a structural piece, a large structural piece, and I'm attaching a small complex piece to that structural piece. Or I'm attaching like a circuit board to some sort of assembly where I need it to be in a very specific place because I'm doing wire channeling. For both of those scenarios, I have to have it be strong, and I have to have it be aligned correctly. And because heat inserts kind of melts all of the plastic, it's very hard to get it flush. I know you're going to say it's a skill issue, but I've done, I've put in hundreds of these brass inserts, and I'm telling you, inserting nuts and printing over it is the future. That's the good point. Like, it's so backwards to do this heat insert thing. Like, the whole point of 3D printing is you can have a complex inner geometry, and not everyone wants to just leave that as empty space for cooling or for if you're making a jet engine. Like, you have an empty space, embed something in that empty space. And I understand why people don't do it, because it's nice to just click something and print it, and you have to pause a print and insert stuff. And then also, like, slicers can't handle it, and CAD programs, it's annoying to do it in CAD programs. If you can solve these two things, ideally, I'm going on too much of a tangent, but putting nuts in 3D prints is the future. And what's great about 3D printing is using stuff like also inserting ball bearings, inserting dowels. I want to do things quickly. Wooden dowels, steel dowels. I want to do things quickly, and there's a temptation in 3D printing is to just make everything out of plastic, make everything 3D printing. You just press a button and then it spits stuff out. That works great for toys. If you're only making toys, then that's fine. But if you want to make functional parts, you're going to have to use multiple materials, and that's just kind of moving forward, I'm going to just utilize that a whole lot, and I'm going to talk about that a lot, and that's why I'm excited about kind of doing rants or doing lectures, because I can share those techniques and hopefully find other people who are using those techniques, and we can all learn from each other and just make a future where we can have parts that are like, the thing about you leaving a hole and doing a heat insert, it's like you're just doing the same injection molding thing. You're just making it more accessible. And yes, that's okay, but it could be so much better. You can do so much more if you do 3D printing techniques, and it's harder to explain because it's like you don't have an example to point to, but it's going to happen. It's going to take a lot of work, but it's going to be great. So I'm really excited about this. Anyway, huge tangent. I'm talking about mechanics. I'm very opinionated on that. In terms of electronics, I am really bad. Look at this mess. Look at how complex this is. This is, okay. This is like borderline, I should have just made a PCB. Like, look at all those traces that I do. Also, if you can kind of look at the external wiring outside of the control box, it's a mess. The thing I don't like about PCBs are great. I just don't like the fact that now there's this changed like over the past couple years. Like, it used to be that you can kind of get a quick American PCB made, and it was like twice the price of a overseas one. Now it's like the overseas one's halved in price and the American one's doubled in price. So like, okay, 2 times, if it's a couple bucks for a board, you can shell that out. Now it's like, okay, now it's 4 times, and also I feel like just the quality has also gone down domestically and up overseas. So it's like, okay, now you kind of have to, effectively for most use cases, the way to do it is you just got to order it overseas, and then I got to wait, right? And then it's like, okay, now I got to put everything on hold. I might get distracted. So if I could just, even if it takes a lot longer and it's a lot less reliable, I'd rather just do things by hand. Now, some things, if I want to cram anything more into that control box, I just physically can't. So I'm going to have to do a PCB, and then it's like, okay, well, Why don't I just like get a mill or a machine? It's like, yeah. I just feel really bad. Like, I come from the software world where there's these great tools and everything's so quick. I just feel really bad for these electronics people. It's like, obviously, like if you're at a shop where, okay, you have your own fab, then that's great. But that's not the majority of people. And especially for people starting, like they don't have access to great tools, and it's just really a pain in the butt. I'm going to skip my wire channel injection mold fantasy. I'm taking too many tangents. Yeah, the other thing that's great about doing PCBs is you can have current protection and thermal protection, which, if you know, please give me suggestions, but I would love to find a way to do it manually. If someone can link me like a bunch of great thermal fuses, resettable, by the way, thermal and electric fuses. Now it's really hard because like now you need resistors perhaps, and then that adds more to your footprints. But, and then like they're probably going to be like $1 or $2 versus like a couple pennies for something you can have on a PCB. Yeah. Basically, I think I'm pinching pennies. You know, I'm like optimizing things too, like thinking about like how much current does this draw, like let me think about this. Yeah. I need a better way to do electronics. And I look at the state of the art for what other people do when they're designing electronics, and I'm not happy about that. I think like my ideal system is I make my own CAN chips, and I could just have maybe a standard board that I can connect all my components to, and just have like one communication protocol, and it'll be a lot of effort, but eventually, like, I just want it to be like, you know, it's so easy, like if you're doing software, to just install a library, and you know, you have a framework to just start moving like super quickly. And in electronics, you're just doing so much stuff from scratch. And I understand it's the physical world, you can't move it around like bits, but you know, I would say like mostly I'm just time constrained. I would yeah, like at this current rate, I'm never going to achieve my goals doing electronics. So I need to come up with a new paradigm to like really rethink how I'm doing stuff. It's a mess. Basically, I'm admitting it's a mess. I don't see anything out there that works. It's not making any sense, but I think I'll figure something out where I can just like do things really quickly. Okay, let me talk about programming a little bit. This is simple, not a lot to do. One thing, when I'm working with hardware, by hardware I mean like electronic stuff, I find that writing component tests really saves me a lot of headache, because with my software, I'm like 90% confident in it. With doing stuff physically, I'm like 25%. So I catch a lot of errors if I just have like really robust component level tests. I do need better tooling for like doing prototyping and breadboarding. There are some like programmable breadboards that I'm really excited about. This is like such a crazy thing about electrical engineering culture, that this has not been the norm. Like, why are these tools only existing now? And then it's like, you know, I can complain a lot like, oh man, they're expensive compared to a breadboard, and they're not exactly intuitive, but like just the people working on that, I really applaud them. I totally see how this can help unlock things for so much better. About programming, I'm not going to talk about it too much because I find it like kind of boring. I've done that a lot. This is not advanced stuff. One thing that I do really like that I can take from the software world is backing up like my models and my schemas on Git, and I can go back and forth. Like, that's something that really helps me move in the physical world a lot faster. Anyway, a lot of changes to these components. Let's see, should I show how this friction works? Here, I'm getting a little tired at this point. I have a little video that I can play. It basically will show you how the locking mechanism works. Basically, I have a clamp on the motor, and then I have a linear actuator. That's the bottom part, and then I have a clamp on one of the gears. And let's see, what do I have? Yeah, I have a little piece of foam that if I compress it, it stops motion, but it slides pretty easily if I don't have compression. So I have a spring and a motor, and basically the locking works really well. The proper use case, if it was a one-off thing, would be to use a solenoid. That's not going to work for a lot of other projects that I have in mind, so I didn't go with that approach. But if I was only doing this, yeah, solenoid would be like so simple, so easy. I think I have 5 wires to this kind of like janky linear motor rather than just simple 2-wire solenoid. But yeah, I bit the bullet temporarily for something in the future, and now it looks a lot more messy and confusing, but it's functional. And yeah, it's 90% of the way there. I'm pretty happy. There's some problems like with the touch, it's not consistent. The speed, I could still tweak the speed and get it better. Also, like, ideally, just like if I wanted to make version 3, I would do wireless, but it's not worth it. I'm 90% of the way there. It's a lot better than that first janky version. I'm happy overall with how things turned out. That last 10% would be really awesome to make it something like, now if you look at my system, you can say like, oh yeah, this is janky, someone put it together. If I just do that final touch, it could be something that's like, wow, it'd be better than everything else. But I don't really care about that. That's not like, I shouldn't say I don't care about that. That would be awesome. It's just not high priority. And if I was better, if I had more skills, and maybe I'll revisit this in a couple years when I do have better skills, and let's say I could work 10 times as quickly, which is, which will be, I'm confident in that. If I get my mechanics from 5 out of 10 to like 7 or 8 out of 10, if I get electronics to maybe 6 or 7 out of 10, if I skill up, collect more tools, I definitely can do a version that would be like better than anything you can buy and cheaper than anything you can buy. I don't think this is too important. I have other high priority stuff, but overall happy. What I can do that is a quick fix is to take all the upgrades that I made for this version and add it to that old version. I'm really dreading that. If I'm gonna change that anyway, I might as well like make some more fixes, but it's tempting. I think the smart thing to do would be to wait a couple months, work on other projects, and see if other issues come up. Realistically, I'm just gonna move on. But yeah, one key takeaway from this project, which I just spent a lot of time ranting, spent hundreds of hours, did a lot of iterations. I learned a lot of frustration. It is satisfying. Not right now, but moving on in the future, it will be very satisfying using it every day. I have to accept I've moved away from this. Sometimes I go too hacky. Sometimes I go too idealistic, do the right thing. I think I should accept hacks more. And if something works well, like not mess with it, not make it perfect, really try to focus on key things. This was good for a learning experience, but I can't afford to do a project like this in the future. I have to be hacky for a while. That's the biggest takeaway. That first version I did, the janky version with the solar system, piece of cloth, and the zip tie motor, that was totally worth it. This is arguably not worth it. I know there were side effects, but yeah. But I did learn some stuff. I think I am aware that I suck at electronics a lot. I think that I know I can get better, but this is kind of a weird thing to say. Even the state of the art, I think, is not enough for me to do what I want. I need to get better than the state of the art, and I'm not sure if catching up to the state of the art is the right path that'll get me better than the state of the art. So I might have to go in a different direction. What I like about, so yeah, why not just outsource electronics, mechanics, right? Why not just, maybe buy a system and just work on the code? I like doing projects where you have to do everything because you discover stuff like design for assembly, right? Let's say I wanted to make something and make it very good and, have it a product that other people use. The fact that I have to actually install it means that I have to become good at design for assembly. And if I just handed it off to someone else and was like, hey, I did my job well. I made it manufacturable and cheap and reliable. assembly is going to be a pain, but that's not my problem. You know, that's not good for the world. That's like a disintegrated view, and the integration like really helps. You know, it's crazy that like I talk about 10 different domains, but the one but to make things truly great, sometimes it's like you have to make one thing excellent, and other times it's like it's a chain, or if any link in the chain breaks, it ruins the whole thing. So I would say that part is more valuable for the current world than the excel at one thing, because a lot of people do excelling at one thing. One thing that would help me speed up a lot, and accepting hacks more, that's the main takeaway. These are just kind of side things that I learned, is I need better simulation tools. Just helps so much, the limited simulation I do. Simulation for like cloth and like for not rigid materials helps. And I know there's packages for that. But you know, they're computationally expensive. I need to find out like a good way to simulate stuff and mock stuff. Yeah. Let's wrap it up. Yeah. If you enjoyed this, let me know. Feel free to give suggestions. Like, I like watching stuff like this. You know, I know it's not the most popular thing, but I really like deep dives on specific topics that people are passionate about. And since I know that this is going to be an unpopular thing, first of all, just because this is a new format I'm trying out, but because this is just a niche thing in general, if you are someone who does like this and you have feedback, I'll probably respond. The thing though is I know I fucked up on like a dozen things here, so I'm going to do this for a couple of different projects. It's very dangerous to like say this, like promise something and then you end up not delivering, but this is not out of the realm of possibilities. If I did this in the past, there could have been like 5 or 10 projects that I could have done a review on that I didn't, just because it's hard to like remember to document things, and also I don't like editing. But you know, if I could just kind of figure out how to give a really good lecture style recap, then I'll definitely do it. So yeah, I just welcome any engagement. Okay, bye. Damn.